Weird sciencey facts that boggle my mind. Everybody's always looking for easy ways to lose weight, but the easiest way might just be changing your location. Because believe it or not, you weigh more on certain parts of the planet than you do on others. Most of us have been introduced to gravity at this point, be it on a bike or down some stairs, or perhaps just trying to keep certain parts from dangling into the toilet water. And gravity interacting with your or anything's mass is what gives it weight. And mass itself creates gravity. The bigger something is, the stronger its gravitational pull. Earth, being a big rock, creates 1 g of gravity. That's the pull that we experience standing on the surface. But the moon, being considerably smaller than Earth, only creates 1/6 of a g. That's why Armstrong and Buzz were all bouncy, because they weigh 1/6 as much on the moon as they do here on Earth. And while I feel like most people are familiar with that concept, the thing I think you might not be familiar with is the fact that gravitational pull on Earth is not consistent. In fact, for us Northerners, it's good news for our beach body because we get lighter when we go on that Caribbean vacation by doing absolutely nothing but going there. And it's not so bad that we get heavier when we go on that Alaskan cruise because we get to cover up. It's chilly. Now, there's a lot of things that affect Earth's gravitational fields, but there's two main ones. First is that you need to think about Earth like that spinny thing from the park that you used to try to kill your friends by getting it going fast enough that they'd fly off of. The closer you are to the North or South Pole, the more it's like sitting in the middle of that thing. You're right on the axis, and you've got less of that centrifugal force trying to fling you off the surface. And the closer you get to the equator, the further you are from that axis. That's like sitting right on the edge of that merry-go-round thing. You're spinning a lot faster, you're having more of that centrifugal force act on you, and that's counteracting Earth's gravitational pull from its mass just a little bit. And the other big factor is density, mass. It goes back to the exact same thing that causes Earth to have its gravity. The denser the Earth is around you and the part of the planet that you're on, the more gravitational pull there's going to be, the more you're going to weigh. So at the ice caps, you've got a lot of frozen water, and all that frozen water on top of the ground is heavy, and it compresses and compacts the ground like a bunch of bowling balls on a memory foam mattress. This makes the ground denser, and it increases the concentration of its gravitational pull. And you're probably like, all right, that's cool, but I don't feel any lighter on the beach in Florida than when I visit Aunt Peg in Wisconsin, so clearly it's not really enough to matter. But you would be wrong. It actually has very profound effects. Effects that are going to affect that Caribbean vacation in the not-so-distant future. Just because you can't feel it doesn't mean it's not acting in very profound ways on the world around you. Think about this. You don't feel the gravitational change from the moon as it passes by you. But sure as a rising tide, with less than an ocean, it can move an ocean. Now, one of the biggest consequences of the world getting hotter is sea levels rising. We hear about it all the time, and, it makes perfect sense, right? As the ice caps melt, more water gets put into the ocean, and the oceans rise. But it's more complicated than that because the oceans don't rise equally, and they don't rise for exactly the reasons you'd think. See, the volume of water in the ocean is only part of what contributes to the ocean's overall level. The other part is that uneven gravitational field. And that stronger gravitational pull at the poles means that the ocean is pulled to the poles, much in the same way that the moon pulls the oceans around to change the tide. But as the ice caps melt, the poles become less dense and their gravity weakens. What's more is the ground becomes less dense because you're pulling those bowling balls off the memory foam mattress and allowing it to puff back up. So as the ice caps melt, there's less gravitational force to hold the oceans at the poles, which means that the oceans will rise in places with less gravitational pull even without the added volume from the melting caps. Now, satellites and modern technology give scientists great tools to monitor Earth's gravitational field and predict how it can change. But it's not an exact science, and its variables, mixed with variables in ocean salinity and ocean currents that are all going to change as the climate changes, makes it a much more difficult and unpredictable equation to predict where, when, and how sea levels are going to rise. Because it's not just as simple as calculating how much liquid the melting ice caps are adding to the glass of water that is our oceans. And the fact that gravity changes with geography, and the fact that those barely detectable gravitational forces are the only thing that's keeping Kevin Costner from filming the sequel of Waterworld in West Palm, well, that is pretty mind-boggling.